There's a moment in science when an experiment gives you an answer you weren't looking for. Not wrong, not broken, just unexpected. And that feeling and that quiet unease is exactly what a growing number of AI researchers are sitting with right now. ChatGPT-5 can solve problems. Most of us knew that was coming, but what nobody fully prepared for is how it's solving them, the paths it takes, the reasoning it constructs, the leaps it makes that when researchers trace them back, don't follow any logic they deliberately taught it. And here's the part that keeps experts up at night. It's not making mistakes. It's getting things right in ways no one can explain. So today, let's slow down and actually think about what that means. First, a word you're going to hear a lot: emergence. You know how a murmuration of starlings works? Thousands of birds moving in perfect fluid waves across the sky. Nobody's in charge. There's no bird at the front drawing the route. The pattern just arises from simple rules, repeated at scale. Something breathtaking and hard to predict appears. That's emergence. And it turns out large language models do it too. As these models get bigger, more parameters, more training data, more compute, something strange happens. They don't just get better at the things they were trained on. They start doing things they were never explicitly trained to do at all. In 2022, a landmark paper from Google Brain documented over 150 emergent abilities, skills that appeared suddenly in large models, almost like a phase transition. Below a certain scale, zero ability. Then something flips. Researchers documented abilities that appeared abruptly, not gradually, as model size crossed certain thresholds. They called this breakthrough emergence. And with ChatGPT-5, researchers are seeing something similar. But now, the capabilities aren't just more impressive. The reasoning process itself has become harder to follow. 150 plus emergent abilities cataloged in frontier models since 2022. Approximately 80% of AI safety researchers say interpretability is still unsolved. GPT-5 shows multi-step reasoning chains that auditors struggle to reconstruct. This is the core tension. Don't rush it. Here's something most people don't think about. OpenAI, the company that built ChatGPT-5, cannot fully read its own model's mind. That's not a criticism. It's just the reality of how these systems work. You don't write a neural network the way you write a recipe. You set up a structure, feed it enormous amounts of data, and let it find its own patterns. What emerges isn't a tidy set of rules. It's billions of weighted connections, a kind of learned intuition that produces outputs even the engineers have to test to understand. A field called mechanistic interpretability is trying to reverse engineer this, to crack open the model and read what's happening inside. Think of it like studying the brain by looking at individual neurons. We can see the inputs and we can see the outputs, but the middle part, the actual reasoning, is still largely a mystery to us. Paraphrased from multiple researchers in the interpretability field with ChatGPT-5, this problem has intensified because the model isn't just answering factual questions, it's doing things like constructing legal arguments, debugging novel code architectures, doing multi-step scientific reasoning. And in these complex tasks, the chain of steps it takes to arrive at a correct answer doesn't always map neatly onto human logic. Researchers at Anthropic, DeepMind, and MIT have all published work in the last year flagging the same concern. Our interpretability tools are lagging behind our capabilities. We're building faster than we can understand. Keep this concrete, no sci-fi, just facts. Let me give you some grounded examples of what this actually looks like. In math, Olympiad-style problems, the kind designed specifically to require creative leaps, not just recall, GPT-5 class models have begun demonstrating solution pathways that don't resemble textbook methods. They arrive at correct answers via steps that seem almost intuitive, shortcutting proofs that would take a human mathematician multiple lines of formal reasoning. In medical diagnostic scenarios, similar patterns emerged. Presented with ambiguous patient cases, the model identified rare disease combinations that stumped simulated panels. But when clinicians asked the model to explain its reasoning, the explanations, while plausible, didn't fully reconstruct the path it actually took. This is called the faithfulness problem. The model can tell you a story about why it reached a conclusion, but that story may not be the actual mechanism that produced it. It's a bit like asking a chess grandmaster why they made a move. They'll give you a reason, but beneath that reason is 20 years of pattern recognition that no verbal explanation can fully capture. The difference, of course, is that with the grandmaster, we at least know a human brain is behind it. With GPT-5, we genuinely aren't sure what kind of process we're dealing with. Measured, honest, acknowledge uncertainty. Now, I want to be clear about something. This isn't a reason to panic, but it is a reason to pay attention. The honest framing is this: we're deploying systems in high-stakes domains, healthcare, law, finance, education, where understanding why a decision was made isn't just nice to have, it's essential. If a model recommends a treatment and is wrong, we need to find where the bias crept in. Right now, our ability to do that is limited, not non-existent. Interpretability research is genuinely progressing, but the gap between capability and understanding is wide, and it's widening. What makes GPT-5 different from previous moments of AI hype is the credibility of the people raising these concerns. This isn't alarmism from the outside, it's engineers and scientists, people who built these systems, who are proud of what they've made, saying clearly, we need to understand this better before we go further. Jeffrey Hinton, Yoshua Bengio, Ilya Sutskever. These aren't fearmongers. These are the people who invented modern deep learning, and they're the ones asking the hardest questions right now. Optimistic but grounded. End on wonder, not worry. Here's how I think about it. For most of human history, we've built tools we understood completely. A hammer, a printing press, a steam engine. We knew exactly how they worked. Then came electricity. And for a while, we used it without really understanding it. We figured out the how long before we nailed down the why. We might be in a similar moment with AI. The capability is here. The understanding is catching up. And the good news is that some of the smartest minds alive are working on interpretability, alignment, and transparency, not as afterthoughts, but as primary research goals. The question isn't whether we can build more powerful AI, we clearly can. The question is whether our understanding of these systems can keep pace with what we're building. That's not a rhetorical question, it's a genuinely open one. And the answer, I think, is going to define the next decade of our relationship with technology. Quiet close, no hard sell, genuine curiosity. If an AI can solve a problem correctly, but neither it nor its creators can fully explain how, is that wisdom or something else entirely? Drop your thoughts below. I read everyone, and if you want to go deeper on interpretability research, the links are in the description.